Hello, my name is Jasmine, and this project explores how grayscale controlled exposure affects surface roughness in resin 3D printing. I use the Prusa SL1S speed, which operates using the MSLA process. Basically, UV light passes through a masked LCD screen to cure each layer of resin. I was interested in what happens when we manipulate the light exposure at a pixel level, especially on the final print layer. The diagram illustrates the MSLA masked stereolithography process used by the Prusa SL1S bead. UV light from an LED panel shines upward through an LCD exposure screen, which selectively masks light to cure specific areas of resin. The print builds layer by layer as the platform lifts the part out of the resin tank after each exposure. This method enables high-resolution printing with precise control over each layer's geometry. To do this, I created 4 identical test pieces, all with the same geometry and print settings. The only difference was the final layer, which I modified using a checkerboard pattern to simulate different UV exposure levels. Each version had a different brightness, from darkest L1 to brightness L4. I generated these patterns using Python, applying a simple checkerboard algorithm that selectively turned pixels on or off based on grayscale intensity. The exposure time was determined using a simple formula: exposure equals the number of active frames times the time per frame. L1 used the fewest active frames and thus received the least UV light, while L4 used the most. After printing, I scanned each part using a coherent scanning interferometer to evaluate the surface roughness. I compared L1, L4, and a controlled part that didn't use any checkerboard pattern. What I found was that the plain model with no grayscale modulation had the roughest and most inconsistent surface. L1 showed sharper peaks and more defined texture due to the limited exposure, while L4 was flatter and smoother thanks to the higher UV dose. This shows that grayscale modulation, even just on the final layer, can impact surface quality in a measurable way. In the future, I'd like to expand this method to full layer or full model modulation and test how it affects not just the surface texture, but also things like mechanical strength or optical clarity.